Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners, and welcome to today's Natural Sciences lesson. My name is Sianda Madlala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, in today's topic, we'll be talking about acids and bases. And basically, we'll be looking straight at the characteristics of acids and bases. So let's quickly look at our lesson objectives for today. Right. Remember that this is what we need to achieve by the end of the day, right? So we better focus here so that we know what we need to know and achieve by the end of this lesson. So by the end of this lesson, we should be able to firstly define acids and bases, right? You should be in a position where you can tell the next person what acids and bases are. Secondly, we need to be able to define the pH scale. Not only that, we need to be able to describe these acids and bases. And also, we need to be able to compare and contrast acids and bases, right? We need to be able to look at the similarities and also the differences of acids and bases. And lastly, we need to be able to analyze the pH scale. Are we together? And all this information is found under the CAPS document on page 67. Right. Now let's quickly look at our pre-knowledge, which is what we have done in the previous grades and probably the same grade, and it lays the foundation to today's topic. So in grade 7, if you remember very well in our grade 7, which is 2 years back, right? In grade 7, we did discuss the topic of acids and bases, right? It was introduced to us, right? So this year we're visiting it again, right? Then in grade 9, which is the same grade that you are in now, we have talked about compounds, we have talked about chemical reactions, we have talked about the reactions of metals with oxygen, and also, which is our last topic that we talked about reactions of non-metals with oxygen. Right. So now let's quickly look at our baseline activity. So our baseline activity has 1, 2, 3 questions, but number 1 has 3 questions to answer as well, right? So I'm going to give you 5 minutes, but firstly, let's go through the questions together. Number 1, it says give the correct names for the following compounds. A, we have H2SO4. B, we have HNO3. C, we have HCl. Then number 2 says give 2 properties of acids, right? So remember from our grade 7 work where we mentioned the properties of acids and bases, right? And number 3, it says give 2 properties of bases, right? So also give from the ones that you remember in grade 7, right? So let's meet again after 5 minutes, then we shall mark together. Welcome back, grade 9s. Now, if you want to send in your answers, comments, or questions regarding this lesson, remember that our WhatsApp number is 079 578 2908. Right, now let's look at the solutions together. Number one was saying give the correct names for the following compounds, right? So I hope this activity was easy for you because we've covered the topic compounds, right? And you can easily identify these compounds, right? So let's look at the solutions. So I want us to move together slowly so that you have time to write these corrections for number one, right? So that I can give you time for number 2 and 3 to complete on your own. Number one, it says give the correct names for the following compounds, right? A is H2SO4, right? What is this H2SO4? H2SO4 is our hydrogen sulfate, right? Which is also known as sulfuric acid. So please mark and as well write down the corrections because I'll be moving slowly with you, right? Then B. B is HNO3, right? What is the name of this compound? The name of this compound is hydrogen nitrate. Are we together? Hydrogen nitrate. Then C, HCl, right? HCl. What is this HCl, right? It is hydrogen chloride, right? Or our hydrochloric acid. Are we together? So H2SO4, it is our hydrogen sulfate or sulfuric acid. HNO3 is our hydrogen nitrate. And HCl is our hydrogen chloride, right? So I hope you had enough time to copy down these corrections, right? So now let's move on to number 2 where I will give you time to copy down corrections on your own. Right. Number 2 said that give 2 properties of acids, right? We know that there are not 2, right? There are many, but we needed only 2. So the first one there is they have a sour taste, right? They have a sour taste and also they feel rough. Not only that, they can turn a blue litmus paper into a red color, right? They turn blue litmus paper red. Also, acids, they have a pH value of less than 7. And usually they have hydrogen in front of the chemical formula. So mark any 2 that you have written amongst these ones. Number 3, give 2 properties of bases, right? Properties of bases, they include having what? A bitter taste, right? Not only a bitter taste, they feel smooth or soapy when as compared to acids, and as well as they turn red litmus paper blue, right? They turn red litmus paper blue, and also they have pH value of more than 7, right? And they may have hydroxide at the end of the chemical formula, and they have the ability of neutralizing an acid, right? So also mark any 2 that you have written amongst these, and I'm going to give you a quick minute to copy down these corrections, and after that we shall continue with our lesson. Welcome back again, grade 9s. Now remember again, if you want us to check your work, you can send in your work on our WhatsApp number, which is 079 2908. Right, now let's move on with our lesson. Starting off with the important terms that we're going to come across as we learn more about acids and bases. The first term that we have there is acids, right? And acids are substances with a pH value between 0 and 7, right? Those are acids. Are substances with a pH value between 0 and 7. We have bases as well, right? Bases, now these are substances that have a pH value of between 7 and 14. Are we together? They have a pH value of between 7 and 14, and those are our bases. Then we have alkali, right? Alkali is the same as bases, right? So it is a synonym for bases, right? So these are bases that can dissolve in water. Then we have corrosive, right? Corrosive now is a substance that dissolves or eats away at metals and other strong materials. So we say such a substance is corrosive. Right. We also have pH, right, which stands for potential hydrogen, right? So pH now is the number between 0 and 14, and that number tells us how acidic or basic a water or basic a water soluble substance is, right? It is the number between 0 and 14, and it tells us how acidic or basic a substance is. Then we have neutral. And neutral are substances that are neither acidic or basic, right? And they have a pH value of 7. Then we have an indicator. An indicator is a dye that has different colors in acids and bases, and it is used to test for the presence of a base or an acid in a substance, right? That is all for our terminology. Now let's get on to our main meal for today, acids and bases. So these acids and bases we're talking about here, they are all around us, right? They are all around us. But now let me ask a question here. Have you ever wondered why different foods or substances taste differently, right? Have you ever asked yourself why different foods and substances taste differently? Why do they not have the same taste? Some taste sour, right? Some taste sour and they make such a reaction on our faces. Some taste bitter and some taste sweet and we enjoy them, right? So have you ever wondered why these foods, they contain different tastes, right? Some are sour, some are bitter, and some are sweet, right? So we're going to find out now on our lesson of acids and bases, right? So as I've said, these acids and bases, they are all around us, right? So to mention some, they include what? Our household substances, right? Such as vinegar, tomato, milk, soap, our drain cleaners, ammonia, baking soda, water, banana, apple, lemon, and so on, right? Now we're talking about the edibles and the ones that we cannot eat as well, right? They are all around us, right? These substances, they are either acidic or basic, or even neutral, right? Not acidic and not basic. Are we together? They are all around us. So if you think of a banana we are familiar with it, right? An apple, we are familiar with it. Milk, we are familiar with it. But now, do we know whether it's acidic or basic, right? Which is what we're going to find out in our lesson for today. Right. So now, starting off with acids, right? So what is an acid really, right? What is really an acid, right? So an acid is a solution that has an excess of what? Of hydrogen ions, right? It has an excess of hydrogen ions. So the more the hydrogen ions, the more the acidic the solution is. Are we together? So it comes from the Latin word acids, that means sharp or sour. Are we together? So as I've said that, the more the hydrogen, the more the acidic the solution is. Are we together? So these are some of the examples of some acidic substances. We have carbonic acid, right, in our fizzy drinks. We have sulfuric acid that makes up our car batteries and paint. We have tartaric acid for what? Beverage manufacturing. We have our nitric acid to make up what? Fertilizers. We have hydrochloric acid that we find in our stomachs. We have also salicylic acid, right? Which is aspirin. We have our acetic acid as vinegar. We have citric acid as citrus fruits, and as well as we have acids that are used in labs, right? So these are some of the examples of acids that we're going to work on for today. So meaning that these solutions here, they have more hydrogen ions, right? And the more they have these hydrogen ions, the more the level of acidity increases. Are we together? Right. Now, bases, right? What is a base, right? Now, comparing these two, right? Acids and bases. What is a base now? A base now is a solution that has an excess of hydroxides. Look at the difference here, right? Acids have an excess of hydrogen ions, right? Whereas bases have an excess of hydroxides, right? So now, another word for bases is alkali, right? Another word for a base is alkali. So bases are substances that can accept hydrogen as well, right? And these are some of the examples of these bases. We have sodium hydroxide that makes up soap, right? We have sodium carbonate for our detergents like washing powders. We have sodium bicarbonate, which is our mix up our baking sodas. We have calcium hydroxide to make up our cement, our chalk, and so on. We have ammonia as well that you can use to make fertilizers. We have magnesium hydroxide for treating acidity as well. We have sodium fluoride that makes up our toothpaste, and we have bases that we use in labs as well, right? So now look at the differences, right? Look at the differences. More of the bases, most of them, they are not edible altogether. So let's move on together so that we see the differences between these acids and bases. So as I've said that these acids and bases, they are all around us. When you look at the examples I've mentioned some substances that we are familiar with, such as washing powders, our cold drinks, bananas, and so on, right? They are all around us, right? So the acid in our stomach, it helps us to digest food, right? And that one is the one that we call what? Hydrochloric and strong at the same time, right? So strong acids and bases are the ones that are dangerous. Are we together? Strong acids and bases can be dangerous, right? So now, how do we measure the level of acidity and alkalinity, right? We use the pH scale, right? The pH scale, right? So the pH of a chemical substance can dissolve what? In water is a measure of how acidic or basic a substance is, right? So the pH scale tells us more about how strong or weak acids or bases are. Are we together? So the pH scale is the range of numbers that tells us how weak or strong an acid is, or how weak or strong a base is. Are we together? And that scale, it ranges from 0 to 14, right? So it is a scale like this, which ranges from 0 all the way to 7, where you find neutral substances, right? Which are neither acidic or basic. Then up until 14, where you have the strongest base. Are we together? So it is a scale that ranges from 0 to 14, and it helps us to identify how strong a certain acid is, or how weak a certain acid is, right? And as well as how strong a base is, and as well as how weak a base is, right? We use this scale and its numbers to identify that, right? So acids have a pH of between 0 to 7. So meaning from 0 to 7, right? Or between 0 and 7, this is where we find our acids, right? And now bases have a pH value or pH scale of between 7 and 14, right? So this is where we would find our bases, right? This is where we would find all our bases in our pH scale. Then right here in the middle, this is where we find what? Neutral substances. By neutral, we mean that they are not acidic and also they are not basic, right? So now let's move on with our lesson again. Now looking at the pH scale, we said that it is a range of numbers and it tells us information as to whether a substance is acidic or basic or even neutral, right? So as you can see, this pH scale is having different colors, right? Different colors to indicate the level of acidity and level of alkalinity as well. Where you have 7 as neutral, right? You have 7 as neutral. These substances are neither basic or acidic, right? So as you move from 7 now, from 7 going down all the way to 0, you start having acids. From 6, you have your weakest acids, all the way to the strongest acids on 1, right? And as well as on the bases, after 7, on 8, you find your weak bases, and all the way to 14, where you find your strongest bases, right? So as I've said that on 1 and 0, this is when you find our strong acids, right? And 14, you find our strong bases, right? These are the ones that we regard as what? As dangerous, right? You find our strong acids and our strong bases, and as well as we find our weak acids around 6 or between 6 and 5. This is where we find our weak acids. Then between 8 and 9, this is where we find our weak bases, right? So to mention some examples here, for our strong acids, for example, we have the hydrochloric acid in our stomachs, right? It is one of the strongest acids as well, right? It is within our stomachs. And now for weak acids, strong bases, we find products such as sodium hydroxide, right? Our bleach and so on, right? Then we find what? Weak acids around 6 and 5. And for example, we have T as one of our weak acids, right? So if you think of the characteristics of acid, I've mentioned that acids, they have a sour taste. So think of your tea as well as you're drinking it, right? It has that touch of a sour taste. So weak bases here, we have bases such as eggs, right, as our weak bases. Right. So now, some examples again of our strong acids and strong bases, and as well as weak acids and weak bases, right? We have hydrochloric acid that I've mentioned in the previous slide. We're having a pH value of 1, right, as one of our strong acids. Then we have sodium hydroxide with a pH value of 14 as our strong base, right? Then also you have milk, right? Milk as one of our weak acids having a pH value of 6. Then we have ammonia, right, as one of our weak bases, right, with a pH value of 1110, right? So now, let's continue with our acids and bases, right? As I've said that, looking at our pH scale as well, right? Our strong acids have the lowest pH numbers. Remember, our pH scale ranges from 0 to 14, right? So our lowest numbers before 7, that's where we find what? Our strong acids, right? And weak acids have a number just below 7, which can be 6 or 5, right? To indicate that they are weak acids. And also strong bases, they have the highest pH numbers, right? Those ones are the ones that range from 14, right? And then weak bases have a number or pH number just above 7, which can be 8 or 9, to indicate that these are weak bases, right? So looking at some examples here, right? As we have said that the lowest numbers, it indicates what? More acidity, right? So here we have at number 1 as our lowest number, we have our gastric juice, our hydrochloric acid, then followed by number 2 where you have what? The lemon juice. Now as we go up, the level of acidity decreases, right? We have apple juice. It is a weak acid compared to the lemon juice, right? It is a weak acid compared to the gastric juice in our stomachs. Then we have tomato juice, which is also a weak acid compared to the apple juice at pH value 3, right? Then we have our coffee, which is a weak acid with a pH value of 5, and it is weak compared to the tomato juice. Then we have our milk, right? Which is the weakest out of them all in this pH scale, right? It is a weak acid compared to all of them, compared to the black coffee, compared to the tomato juice, compared to the apple juice, lemon juice, and gastric juice, right? Then right there at 7, we have our pure water, which is neither acidic or basic. It is neutral, right? It is neutral. It is not basic and it is not acidic. Then just after our 7 here, we find our eggs, right? Eggs now have a pH value of 8, right? So these now are our weak bases. Now, as we increase with the number, right, the level of alkalinity is increasing as well, right? Looking at this baking soda here, this baking soda is more basic than the eggs, right? This hand soap here is more basic than the eggs and the baking soda, right? The ammonia solution is more basic compared to the hand soap, the baking soda, and as well as the eggs. Then we have our bleach here with the pH value of 12, and it is more basic compared to the ammonia solution, the hand soap, the baking soda, and the eggs, right? Then we have the strongest base, which is our concentrated solutions of alkalis, right? So this is how it goes when looking at the pH scale. So let's not forget that our strongest acids have the lowest pH number. Our strongest bases, they have the highest pH number. And our neutral substances are on pH value 7. Right. So now we have activity 1 that I would like for us to use and test ourselves so far, right? Let's go through the questions together. Number 1, it says classify each of the following as an acid or a base, right? So you need to look at the description and tell us whether it's an acid or a base, right? The first one there, it feels soapy and smooth. The second one can neutralize an acid. The third one, found in green plums and grapes, taste bitter, handy Andy, caustic soda, physical drinks, gastric juices, pH of 9 and pH of 1. Simply tell us whether it's a base or an acid. So let's meet again after 5 minutes, then we shall mark together. Welcome back again, grade 9s. Now let's look at our solutions. Right, we simply needed to classify each of the following as an acid or a base, right? So let's move together so that you have time to write corrections as well, right? We're going to move together slowly again. The description below, it says it feels soapy and smooth, right? So is that an acid or a base, right? And the answer, it is what? It is a base, right? It is what? It is a base. So don't forget to mark. Then it can neutralize an acid, right? It has the ability to make an acid weak, right? That is a base again, right? It is found in green plums and grapes, right? Those are acids, right? It is an acid. It tastes bitter. That is a base, right? It is a base. Handy Andy, remember Handy Andy sells ammonia, right? It is what? A base again. Now caustic soda. Caustic soda is an acid, right? Physical drinks, those are acids as well, right? It is an acid. It is an acid. Now gastric juices, that is an acid. pH value of 9, that is what? A base. Then pH value of 1, that is an acid. Are we together? So now let's quickly move on to properties of acids, right? So now, properties of acids, we're talking of qualities of acids, right? Characteristics of acids. So these acids, as I've said even in our baseline activity, they have a sour taste, right? They have a sour taste. Also, they feel rough, right? They have a sour taste that makes your face curl as you eat such acids, right? And also they turn blue litmus paper red. So if you are testing for alkalinity and acidity using litmus paper, the blue litmus paper turns red to indicate what? There's a presence of an acid in that solution. Also, they have a pH value of less than 7, right? Remember, it ranges from between 0 and 7. And also, they usually have hydrogen in front of the chemical formula, right? And also, they can neutralize a base, right? What do we mean when we say they can neutralize a base? Meaning that they can make a base to become weak, right? They can make a base to become weak, right? Also, they are soluble in water, right? So the examples of these acids, right? We have hydrochloric acid, right? That is found in our stomach as well. Hydrochloric acid with the chemical symbol HCl. We also have sulfuric acid with the symbol H2SO4. We have nitric acid as HNO3, and we have vinegar as acetic acid, and we have what? Citric acid in our citrus fruits, right? So most acidic products, they have warning signs such as this, right? To tell you that this product is acidic, right? So they have signs like this that's written danger, corrosive, or warning acid, right? Now, let's look at the examples of acids and their uses, right? And specifically looking at nitric acid, right? So this nitric acid is used in the production of ammonium nitrate for fertilizers, for making plastics, and also in the manufacturing of dyes, right? So this is what our nitric acid, right? Also, citric acid is one of the examples, right? So this one is a weak organic acid. It occurs naturally, and mostly it is found in fruits, and in particular citrus fruits such as limes, oranges, and lemons, right? And also this citric acid is a naturally occurring antioxidant, right? So as you can see, our examples is found in lemons and our sour sweets. Now, what are the uses of acids, right? As I've said that acetic acid is used for vinegar. Citric acid is found in our lemons, limes, and oranges, right? And it is in many sour candies such as lemon head and sour patches. Then the ascorbic acid, right? This one is our vitamin C that our body needs the most to function, right? Then we have sulfuric acid that is used in the production of fertilizers, steel, paints, plastics, and also car batteries, right? And also our hydrochloric acid that is found in our stomachs. Right. Now looking at the properties of bases, right? We said bases have a bitter taste, right? They taste bitter. Also, they feel smooth and soapy. Not only that, if we were to test for the level of alkalinity and acidity, they turn the red colored litmus paper blue, right? The blue color indicates that there is a presence of a base in that solution, right? And they have a pH value of more than 7 because they range between 7 and 14. Also, they may have hydroxide at the end of the chemical formula and they have the ability of neutralizing an acid, right? They can make an acid to become weak. Right. So examples of these bases, we have sodium hydroxide, which is used to make what? Hand soap, for example. And the chemical formula for sodium hydroxide is NaOH, right? Then we have calcium hydroxide, which is CaOH2, right? And is used to make lime. And we have ammonium hydroxide as NH4OH, right? Which is used to make our kitchen cleaners, our cream cleaner, or our ammonia, right? We also have sodium bicarbonate with the chemical formula NaHCO3, right? It is used to make our baking sodas as well. For example, now also let's look at the uses of these bases. So these bases, they give soaps, ammonia, and many other cleaning products some of their useful properties because they contain what? The hydroxide ions. And the hydroxide ions, they interact strongly with certain substances such as dirt and grease, right? So the ability to clean what? Products, right? So chalk and oven cleaner as examples of bases, right? They contain what? So the chalk and oven cleaners, they contain what? Hydroxide as well, and they are bases. Right. So let's quickly move on to our activity 2. Right? So activity 2, we have the instruction here that says use the picture alongside to answer the following questions, right? The picture here is showing someone who is facing what? Indigestion, right? So number 1 is saying, what do you think caused the indigestion? Number 2, suggest one way in which the person's indigestion can be treated. Number 3, explain why the person should not be given a fizzy drink. Whereas for number 4, it says name one way that indigestion can be prevented. So I'm going to give you 5 minutes for this activity. When you are done, we can mark together. Welcome back again, grade 9s. Let's quickly look at our solutions, right? Number 1, what do you think caused the indigestion, right? The answer is the person could have heartburn and as a result of eating unhealthy food or drinking what? Physical drinks, right? So indigestion is a result of the production of too much hydrochloric acid in the stomach, right? So give yourself a tick. Number 2, by suggest one way in which the person's indigestion can be treated, right? So it can be treated by taking an antacid or substance such as baking soda in water. Why such substances? This is because they can neutralize acids, right? Bases, they can neutralize what? Acids. So they can make the acid to become weak. This is why the person needs to take a baking soda, because baking soda is a base, right? Or an antacid that can neutralize the acid in the stomach. Number 3, explain why the person should not be given a fizzy drink, right? This is because fizzy drinks are acidic, right? And they will only make the heartburn to become worse. This is why the person should not be given a fizzy drink in such a situation. Then number 4, right? Name one way that indigestion can be prevented, right? Simply by reducing the consumption of foods that are too acidic and reducing what? Fizzy drinks, right? This is how you can prevent heartburn. So I'm going to give you a quick 2 minutes to copy down the corrections. Then after that, we shall summarize what you have learned for today. Welcome back again, grade 9. So we have been waiting for those answers, questions or comments on our WhatsApp number, which is 0795782908, right? But now let's summarize what we have learned for today. Right. The topic for today was about acids and bases, right? And basically the characteristics of these acids and bases. So we said that an acid is a solution that has an excess of what? Hydrogen ions, right? So it comes from the Latin word acids, which means sharp or sour. So we said that also the more the hydrogen in a solution, the more the acidic the solution is, right? And we said that a base is a solution that has an excess of hydroxides, right? Also, the same goes for it. More hydroxides, the more basic the solution is. Are we together? So we said that these acids and bases, they are all around us, right? So to mention some, we talked about bananas, apples, soap, cleaning, drain cleaners, cleaning detergents, and so on, right? They are all around us. Some you can be able to eat them, and some you cannot be able to eat them, right? And we said that both these acids and bases can be strong or weak, right? Where you have strong acids and bases being dangerous, right? Strong acids and bases are dangerous. Also, we talked about what? The measurement of acidity and alkalinity, right? We said that we use a pH scale to measure whether a solution is acidic, basic, or neutral, right? So we said that the pH of a chemical substance that can dissolve in water is a measure of how acidic or basic that substance is, as I've just said now. And we said that the pH scale, I repeat, the pH scale tells us how strong or weak acids and bases are, right? And we said that this pH scale ranges from 0 to 14. And I even drew this to say that it ranges like this. It is a scale that ranges from 0 all the way to 14, where you have the 7 as our neutral substances, right? And between 0 and 7, it's where you find what? Our acids. Then between 7 and 14, it's where you find our bases. Are we together? Then we said that 7 is of our neutral substances. Right. So here we have again the pH scale, right? So looking at this pH scale, we have our pure water as neutral at the pH value of 7. Then we have our strongest acid at the pH value of 1, which is our stomach acid. We have our lemon juice as our weak acid from the stomach acid. We have coffee as well as one of what our weak acids. Then after the neutral substance, we start finding bases, right? We have our seawater as one of the weak bases, baking soda as one of our weak bases. Now it starts getting stronger at our ammonia at pH 11, then our bleach as one of our strongest bases, right? So also this table summarizes what we have learned for today, right? We said that acids have a pH less than 7. They turn red litmus paper into a red color. They taste sour. They sting or just feel wet. And in the examples include fruit juices, soda, and coffee. For our bases, we said that they have a pH value of greater than 7. They turn litmus paper blue. They taste bitter or soapy. They feel slippery. And examples include baking soda, ammonia, and soap. So who can guess what we're going to learn about in our next lesson? Our next lesson will be on pH value, right? Our next lesson will be on pH values. We'll be talking more about the pH scale in our next lesson. So from me to you now, thank you and goodbye.